2, we learned a way to multiply polynomials, and using the FOIL pattern is the usual way that you do that. However, in 10.3, we're going to learn about some special products of polynomials or some patterns. So if you want to make note of these patterns, we have two separate patterns here, the sum and difference pattern and the square of the binomial pattern. Now, both of these can be proved if we do the FOIL method. However, this is a little bit of a shortcut, and I have it on each one of the screens. So, find the product of 5t minus 2 and 5t plus 2. So, if you notice, that's the same as the pattern. We have a plus b, a minus b. So my answer is going to be a squared minus b squared. I'm going to go ahead and do the shortcut first, and then I'll prove it to you with FOIL, and then we'll just start using the patterns for the other examples. So in this case, it says a, which is going to be this one, is going to be a squared, so 5t squared. And then it says that it's going to be a squared minus b squared. And b squared would be the 2 squared. Sorry. Okay, now I can multiply that out, the second one, so it's going to be 5t squared minus 4. Okay, whoops, I'm sorry. I could have done more multiplication than that, couldn't I have? Let's do 25t squared minus 4. Now, let's go ahead and show this one in the FOIL method and see if we come up with that same answer. So if I do 5t minus 2, 5t plus 2. First would be 5t times 5t, which would be 25t squared, looking good so far. My outside, 5t times a positive 2, which would be a positive 10t. And then a negative 2, my inside would be negative 2 times 5t, which would be a negative 10t. And then negative 2 times a positive 2 would be a negative 4. Simplifying there, I'm going to get the same answer as I did applying the pattern and using that shortcut. So, moving on to example 2, squaring a binomial. Letter A is going with the sum squared pattern, and you can see it's supposed to give us a squared plus 2ab plus b squared. So that would be 3n squared is my a squared plus 2 times my a, which is 3n, and also times my b, which is 4. And then I'm going to go ahead and say that's plus 4 squared. Now, when I do that, I have some simplifying to do. We would get 9n squared, and then we would get 3n times 2 times 4. 2 times 4 is 8, so I'm going to get, we're all positive there, 24n. And then 4 squared would be 16. Okay? Again, if I work that out to check it, I would get that same answer. I'll just switch colors here since we're kind of close here. This time, I'm going to use the difference, squaring the difference. Again, I'm going to get a squared, which would be 2x squared, minus 2. My a is 2x, and my b is a negative 7y, and then that's going to be times 7 squared. Okay? And I'm going to, oh, I forgot my y in there, didn't I? 7y squared. Okay, now my next step then would be to go ahead and multiply or simplify anything I can. So I would get 4x squared, and then I would get a negative 2 times a negative 7y. That's going to give me a positive 14y times 2, which is going to give me a positive, 14 times 2 would give me a positive 28xy. Okay? Let's see. We had a minus 2. Oh, did I bring down my negative? I did. I made my mistake here. my B term is just a 7. My B term here is just a 7 because the operational symbol is taken care of in the pattern. Sorry about that. And then my minus 7y, that should actually be a plus, because that's my b squared. And so plus 7y, that would end up being 49y squared. All right, so let's see. I have a 4x squared, and then, boy, I really messed this one up, didn't I? I need my subtraction sign in there. Got carried away with calibrating here. I was having some difficulty. All righty. So, I had my negative here, and then I got worried about my spacing, and I messed up there. So, following the pattern, the operational symbols will be applied from the pattern. So you're looking at simply the terms, as I showed you in the 7y. Moving on to applying those special products with mental math. So if we wanted to be impressive and be able to say what 17 times 23 is, I could go ahead and I could say, is there somehow I could apply one of those patterns? I'm going to apply the pattern of the products of a difference or a sum. So I look at these two numbers and I see the one thing they have in common is they both I could get to both of them in a product or a sum with 20. I could get to 17 by saying 20 minus 3, and I could get to 23 by saying 20 plus 3. All right, because I have the same term here, and then I have my opposite terms here, I can use the pattern for the sum and difference pattern. So that's going to be that my answer is going to be a squared minus b squared. So when I look at that, my a term would be my 20 squared, and that's going to be minus my b term, which is 3, and we're going to square that. So 20 squared is 400, minus 3 squared is 9, and again, all mental math this way, 391. So 17 times 23, boom, 391. You need to look to see if there's a way we could use one of those products, because both of these numbers could be used with a sum and difference of 20. We could go ahead and apply the sum and difference pattern. Now, how about 29 squared? 29 squared could also be 30 minus 1 squared. This time, I can go ahead and I can apply that rule, and that rule would be the a minus b squared. That's the square of a binomial, and that's going to be the a squared, the one I messed up so bad on the last screen. A squared minus 2ab, and then that's plus b squared. Confession, I made sure I watched that so I wouldn't mess it up again for you. All right, so now let's go ahead and see if I can make it through my last step. My a squared then would be 30 squared. That's going to be minus 2 times my a, 30, and my b, 1. I'm going to just write it there so you see that I did use that term. And then that's going to be plus my b term, 1 squared. Okay, so I have then, 30 squared would be my 900 minus 60 plus 1. That should be mental math for you again, 841. So using our patterns, we can go ahead and change one that would be maybe difficult into pattern form so that we could do it mentally. Now the next one is going to talk about finding area. And if you want to, you can pause a minute and just kind of look at it. Basically, they've set up everything, and I've just copied it from the book there for you. If we need to find the expression for the area of the blue region, because there's that little bit of red region out of it, we would need to use the area of the blue region equals the area of this entire square. And then we're going to subtract that little bit of red region in there. So the area of the blue region is what we're trying to find, so that's just going to be the area. The area of the entire square, see a pattern coming on there, x plus 3 squared, because both sides are x plus 3. And then the area of that red square, we have x plus 1 on this side, and we have x minus 1, I'm going to just write that in there, x minus 1 on the other side. Okay, we've taken off this little shade here, and we've added the shade on this part. So moving all that to a new screen so we can do some work on that, we're going to apply some of our pattern rules. So x plus 3 squared, I can go ahead and apply that pattern, and that's going to give me x squared, starting to remember these a little bit, plus 2 times a times b. A was 1, so I'm just going to put my b in there. And then I'm going to go ahead and, make sure I put my x in there. And then I can go ahead and square my last term, plus 9. The way I remember it always is, if it's the product of an addition, we're going to have nothing but addition or positive signs in there. Now we go to the x plus 1 and the x minus 1, and we're going to apply that pattern. That will turn into, remember, the O and the I are going to cancel each other out. We're going to subtract this still because that's the red area we want to get rid of. So we're going to have our first term, x squared, and we're going to have our last term, which would be negative 1. Okay, applying that pattern. Now we need to do some simplifying. First thing I'm going to do is I'm going to use, I guess I multiplied that out 2 for us. And then I'm going to use the distributive property here because I have this negative before the parentheses, so it's going to make everything the opposite. That's going to be a negative x squared and a positive 1. Now I can look for like terms. My x squared term gets canceled out with a negative x squared. The only x term I have is 6x. And then I have 2 constant terms, plus 9 and plus 1. So that would be plus 10. And that is my final simplified equation for the area of the blue, or the blue area of that square. And then finally, the last example is another one of those that you could just pause and read that, and it will explain. It's very similar to the one right before that, and you can pause that and see how they've done each. I've provided the solution key in there for you so that you can see where they found each one of those equations from. And that concludes lesson 10.2.